Hello, everyone. My name is Behrouz Hassanbeygi. I'm working as Senior DevOps Engineer at Darumatic. And today I'm going to present multi-cloud Kubernetes using K3s and WireGuard for multi-cloud architecture. So here I have a comparison between two different architecture. One is more common here, which you running your own cluster, AKS, EKS, GKE, or all managed your own self-hosted cluster somewhere. So you're using load balancing, DNS, service mesh. Some service mesh right now supporting this kind of feature that you can divide cluster between east and west, like linkered, Istio. And another architecture we are going to talk about today is single cluster that we stretch through different regions. Like we are stretching our cluster into two region A, B, like into AWS, GCP, and Azure. So right now we are going to talk about this more. So what is the pros and cons of each one of architecture? So as it's obvious, having managed cluster is easier. Like you can create AKS, EKS, GKE with ease, like just snap a finger and then you can create a cluster. But the issue is come with cluster connectivity. So when you want to load balance between two different clusters, you can easily, let's say, create a mess because it's difficult to running workloads into a different cluster. Basically, you need to handle this part with GitHubs. And you need to think carefully that how I need to put my workloads into two different clusters. And in contrast, multi-cloud or a stretched single cloud is simple in networking sense. So we are going to talk about networking more. But what is the actual use cases? Because here, this one is more used today because of the low latency for applications. Like right now, application all connected in a single cluster, database, application, everything connecting to each other, and it's lower latency. But here, one of the major use cases for this kind of cluster, for multi-cloud or cluster, is for edge cases or IoT devices that are in different geographical distances. Let's switch to the next slide. So as you can see, here we have other benefits for multi-cloud. For example, its resilience. So you know that recently some of the cloud providers went down, and it affected a lot of people. So the resilience, it means that if you lose a vendor completely, you're not going to use any users, any live application. Of course, this is very complex architecture, so you need to take care of all aspects. If you leave your DNS somewhere and then you move your workload somewhere else, if the DNS goes down, then you're lost. So it's better to think about all aspects of it. Cost, of course, because then you are not vendor locked, so you can switch between different vendors easily with this architecture. And but it comes with the real challenge. How do we make pods in different clouds to talk to each other securely and efficiently? So first, we are going to talk about security. So for the first part, which is the networking, we want to make sure that the traffic that goes through the internet is fast and secure. So we have traditional VPNs like OpenVPN, which is good, secure, but it's slow because it's running in user space. But WireGuard is running in a kernel space, which means that it's faster. It's using UDP, so it doesn't have basically triple handshake for TCP, which is make it unreliable and slow. And it is perfect for this scenario. So let's talk about this more. So for this architecture, I use these tools. Of course, Terraform is missed here, but it's standard nowadays. So we are going to use Terraform for creating our VMs into different clouds, and then Ansible to configuring our WireGuard network. And after that, using K3s, my favorite small Kubernetes cluster, that we are creating without kube-proxy. Later I will explain why we are replacing kube-proxy, but this is important part. And then Cilium for our CNI. This is the steps that how we creating the cluster. So Terraform provision the VMs, and then each VM gets a public IP address from the WireGuard. Basically, WireGuard creates a mesh network for us. So every node connects to every node. So you have a flat network that all nodes are connected to each other. And later in benchmark, I faced an issue. Like the node-to-node traffic was fine. Everything was working flawlessly. But the issue was whenever I sending traffic to the service, it was working inconsistent. So the issue was underlying into the service. And basically, it couldn't send traffic smart enough to the zone itself. So it was sending traffic to a pod way far ahead from that pod. So the issue was kube-proxy, because kube-proxy was not matched with CNI. At that point, I was using Flannel. Flannel is very common and easy to set up CNI for Kubernetes, which means that it's a container network interface. And then the issue was that it wasn't unaware of our design, because we were stretching our cluster into the GCP, AWS, and Azure. And it wasn't able to recognize that, hey, these nodes are running in other cluster. Basically, I was using zone-aware hints on service, which is basically a feature in Kubernetes, but it wasn't respecting that. So what was the solution? Cilium was the answer to this issue. First, I replaced the kube-proxy with Cilium, and then after that, another useful feature was service topology true, which gave me the feature to send the traffic to the fastest or next zone of my pod. So in this sense, when I'm sending traffic to service send traffic to my pod or to the next cloud pod, or to the fastest pod that can be achieved. So the next question is that how fast it was, how fast this experiment was. So the multi-cloud shows exceptional same node performance. So as we expected, when you send traffic to the same node, you have excellent latency. And for cross-cloud connectivity, for majority of cases, like 90% of the requests were less than 5.4 milliseconds. Of course, all of these zones were running in Sydney. So if you were in a different geographical location than Sydney, because all AWS, GKE, all Google Cloud, AWS, and Azure VMs were running in Sydney. And intelligent routing significantly minimize overall the worst case scenarios when we send this traffic to the service. So the next question is that what we can run on this architecture. So it's good for a stateless API and asynchronous workloads. Of course, it's very easy to run asynchronous workloads. The next scenario is the database read replicas perform excellency across zones. So it means that you can run your database not active, but active passive, which means that they are asynchronous databases, not synchronous. In any use cases, it's better to have active on like the lowest latency architectures. So the key takeaway here is that building multi-cloud overlay with WireGuard is surprisingly easy. So you can just create your own virtual machines or bare metals in any geographical location, and then using Ansible to install your own WireGuard with your shared keys. But the real challenge making Kubernetes service routing kube-proxy aware of the new topology. So you need to replace the kube-proxy. I'll really suggest that doing that thing. And Cilium is perfect hero for this story, combining kube-proxy replacement with load balancer service topology. So I'm going to live demo what we did actually, so you can see what's happening in our cluster. So here, okay, this is a shiny, beautiful terminal. I know that you all love the terminal, so. So let me show you the nodes. Here are the nodes. So 2 of the nodes are running in AWS. As you can see here on the kernel version, we have AWS. 2 of the nodes are running in GCP, and 2 other nodes are running in Azure. So if I get the pods, you can see all pods are running, and Cilium is running as a daemon set on all nodes. And we have these 3 databases. I created these databases using PG Postgre database, and I spread it through 3 different zones. And I connected the DB app. This DB app is a consumer of database. Basically, it's connected to the database and read records or write record to the database. So what I'm going to do now is to shut down AWS zone. So let me switch to the AWS instances, and let me share the screen. Yeah, I'll switch that now. So I know that you are all familiar with this current dashboard, so I'm gonna do the disaster and stop instances. So both of the instances having the static IP address, which means that if I'm shutting down the nodes, next time that I'm starting the nodes, they are getting the same IP address. This is important. In AWS, whenever you don't attaching the elastic IP to your nodes, it's basically you're losing your IP address. So that's important. And soon we should see that the nodes are not available or ready anymore. So it's taking sometimes, okay, I need to switch the terminal again.
How did Cilium figure out the dynamic IP?
Okay, the dynamic IP addresses?
Yeah.
I hope so, but I don't think that's possible at this point. The WireGuard should take care of that part, because the WireGuard is in the underlying level. So whenever we change the IP address, I can. Okay, as you can see, the nodes are in a not ready state, but we are still connecting to the cluster.
Can I ask a quick question?
Yeah.
So this kubectl get nodes, right? It's returning nodes from several clusters, right?
Yes, exactly.
How is it possible?
No,
It's one cluster. One cluster stretched through the different zones. So the way you can connect it to the API server is to setting a load balancer front of your cluster, and whenever one of your API server is down, sending traffic to the one of another API server. Yeah, exactly. So basically, I'm using Cloudflare tunnel to sending traffic to my cluster. As you can see, right now I'm getting the response from my cluster, because the master node was AWS, but when I switch it to the disaster happened, both database and application switched to the different cloud, and everything works. So the configuration for Cloudflare tunnel, let me show you that. This is like interesting part, because instead of using some egress, I'm using service directly, which means that whenever Cloudflare get the traffic, it sends traffic directly to the service, and service find the fastest and nearest pod next to the Cloudflare tunnel. This is, by this way, we are guaranteed that user get the fastest response. Any question? Excuse me? Where is the global load balancer running? In this scenario, we are not using global load balancer. Basically, we are using WireGuard to creating the flat network, and everything's run on top of the WireGuard network. So the pods, like Cloudflare pod, is running in another node and sending traffic to the workload. Let me show you the picture, the pods again. Okay.
Kudos for typing with one hand, by the way.
Thank you. So here you can see we have running 3 Cloudflare pod. These are the tunnels. So if we lose any of these, the other one can handle the traffic for us.
That's
Okay.
one pod between one tunnel between each cloud. Where they're tunneling from?
It's basically for exposing our application deployment to the world. So we have different ways to exposing application. We have ingress, we have BGP, we have Cloudflare tunnel. In this scenario, the easiest way to, let's say, expanding our geographical location was to using Cloudflare tunnel. But depend on the severity of the use cases. For example, you remember that Cloudflare went down, so you don't want that case to happen for you. So maybe in resilience cases, some important resilience cases, you get rid of the whole Cloudflare, and instead of that, using some public IP addresses, any CAS BGP, that can be possible. Okay.
So it's quite impressive, yeah. But I'm curious, how is it specific to K3s to be able to deploy all that? You know, what about other flavors?
Yeah, you know, to save costs, I used very little VMs, like 1 core, 2 GB of RAM, and K3s is very lightweight distribution, so you don't need tons of memory and resources to run your cluster. And it's good for edge cases, so it's a good demo for those people who are looking for, let's say, running their Kubernetes on NanoPi or some edge devices somewhere on internet instead of creating their own private network, you know?
Yeah, but all these technologies used, are they like compatible with any Kubernetes?
Yes, it's a flavor of distribution of Kubernetes, and it supports every API resources that you can imagine. Basically, Rancher is using K3s to create the RKE2 cluster, so they are supporting this kind of product.
So why don't install separate, Kubernetes clusters per cloud and connect with something like Submariner?
Yeah, I covered that in the first slide. Here, let me switch to the slide again so we can talk about that. That's a great question. Here on the architecture, basically it's easier when you have different clusters. You can use GitHubs like Argo CD and deploy your application to region A and B at the same time. But then you push the complexity to developers. You care about your own service availability. But here in this design, we make the network flat, so you care about the networking and everything as an administrator.
Pretty much multi-cluster management becomes important to the cluster itself because cluster is distributed.
Yep.
Okay, that's interesting.
Yep.
Have you thought about scaling this at all, or is this more proof of concept that wouldn't scale?
It's scale, of course, because of the WireGuard, so you can scale it to the whole world. But of course, the thing is that how well you want to create your architecture, what kind of scenarios that you want to create this for.
Node scaling, sort of things, that would be hard, right?
Well, it depends.
That doesn't sound critical at all. It's like,
Yeah, I can show you a bit of the code. So I tried to make it a bit easier to scale. Of course, this is my way of doing things. So, sorry, it's hard to work with one hand. So here I have the Terraform code. As you can see, I'm using this inventory Terraform file. So whenever I'm creating a cloud, a new VM in any cloud, I'm creating the inventory for Ansible. So the next thing that I need to do is just pressing Ansible playbook, and then this will create another WireGuard node for me.
I wanted to ask about LCD and
Okay.
quorum.
Okay.
We know that it's sensitive to latency.
Oh, yes, exactly. But 5 milliseconds is good for etcd. At the moment, etcd is running on nodes. So right now, 2 of the nodes are down, but nothing has happened to the cluster. So we can see that the cluster is functional. You know?
How LCD is deployed? What are the masters of these clusters?
Oh, great question. The etcd is embedded with the K3s. This is the way to deploying it. Of course, there are other ways, like you can have external etcd cluster connected to your cluster, but this is the fastest and easiest way to operating your etcd.
So how are there 3 masters? Are they deployed across clouds?
Can you repeat your question, please? Sorry.
Yeah, this LCD, you know, you need to have quorum, right?
Yeah,
For
exactly.
example, 3 masters, each of them should run LCD pod something. So in this setup, was this configuration somehow instructed about how to place LCD, or it is just came this K3s magically, or what?
Oh, okay. So I put it the etcd, as you can see. Let me just use dash or wide so you can see the actual nodes. So here we have etcd and control plane on AWS, like this first node and second nodes are running on AWS. And this one, node 3 and 5 is running in GCP and Azure. So all spread it through different clouds.
So latency was good enough for it to function.
Exactly.
What about production load? Did you try something like production load?
Well, I used iPref to imitate the actual traffic. So the traffic I generated was like the maximum amount of possibility. So it was 750 megabyte per second different between each cloud. And yeah.
Yeah, because the stretch cluster, there is a pattern, kind of anti-pattern.
Yes.
For many people at least. So this looks a little bit like stretch cluster, but it works well, right?
Yes, exactly. It's because of they are all running in the same geographical location. So they are all in Sydney. But if it was in Germany, the whole thing was completely different. Yeah.
So for the cross-cloud VPN or networking, you have to expose the public IP address.
Yes, exactly.
So where for internet, right?
Yeah, it goes through the internet.
But it's not really secure for sensitive applications.
It's well secure because you're using WireGuard. So WireGuard.
For sensitive applications, the organization won't allow you to open public at all.
Well, if you're not allowed to open your VPN, it means that you cannot create your own private network. That's it. Okay.
Yeah, I think for this kind of example use case, it is secure enough, but it is like having, encrypted network over public internet. If it is IPsec secured, something like that, it can be acceptable, right? But of course, having it absolutely private is better from security perspective, right? But there are trade-offs.
Thank you everyone for listening to my presentation. I'll invite Faisal for the next. Oh, okay. Let's ask Felix to coordinate the thing for us. Yeah, thank you. Thank you everyone. This is yours.
Thank you.